Morning, everybody. For this week, for our notes, we're actually going to be working in the practice set starting on page 12 with solving powerlifting. So I kind of alluded to this last week that in this section, we are going to be learning about all the different types of solving and kind of how to reason our way through of how do I know when to do what. So identifying what type of equation do we have? Is it exponential? Is it a logarithmic equation? And then how do I go about solving it? Because all these different problems have their own nuances. So this is where we're really going to kind of work on our thought process with approaching these problems. And then later in the homework packet, where we get into the solving showdown page on page 15, this is where you will be able to just see one of these problems out in the wild and be able to figure out what solving method you should do. So we're going to be starting on page 12. So you may want to hold off on doing page 10 and 11 until we've gone through the entire solving powerlifting section, just so you can get additional practice with just seeing a problem and knowing how to do what type of solving. So we're going to write a few different steps and strategies up at the top of this page. So up by the name portion, I want you to write exponential, because that is going to be our first type of equation. To solve an exponential equation, our first step is always going to be isolating the bases first. Then our goal is to try to get the same bases so that we can set the powers equal to each other. Or if we can't get the same bases, then we are going to use logging as an operation and log both sides. And you can either use log or natural log, so common log base 10, or natural log, which is log base e, depending on what bases you have involved in your exponential equation. Something to note about exponentials is that there are no extraneous solutions. So we're still going to be checking ourselves for accuracy, but there's not going to be any that we can solve algebraically, but then the solutions don't actually work when we plug them in. So we're going to go ahead and run with this on our first block of problems and see what these exponentials look like. So starting with number 1, I first identify this as an exponential equation because of the location of my variables. I got a variable in the exponent here, and I've got a variable in the exponent on the right side as well. So that's how I identify this as an exponential equation. Next, we want to make sure our bases are isolated. Is 3 as isolated as it can be? Yep, there's no coefficient, nothing getting multiplied or added to the base itself. So both 3 and 9 are isolated. So our next step is to try to get the same bases. So again, I don't want to square the 3 to make it look like the 9. That would be using an algebraic operation, and that would actually make the 3 into a 9 and the 9 into an 81. So we're not squaring both sides. We are replacing the bigger base with a smaller base that matches our base on the other side. So this will remain 3 to the x minus 4 equals 9 turns into 3 squared, and then x plus 28. Now from here, before I cross off my same bases, I first want to distribute that exponent of 2 and simplify my powers. So 3 to the x minus 4 equals 3 to the 2x plus 56. So now that I have the same bases, we can cross those off and set the exponents equal to each other. So x minus 4 equals 2x plus 56. And notice that after we get the same bases and are able to cross them off, we now have a ground level equation. And what I mean by ground level is that our variables have moved from their exponent positions to a ground level, more algebra 1 type equation position. So now that I'm looking at this ground level equation, how do we solve for x? Well, we want to try to isolate x. So let's go ahead and move our x's over to the same side. So I'm going to subtract x, because I like to keep my coefficients positive. And then I'm going to move that 56 over to the left side. So negative 60 equals x. So I can go ahead and just straight up put a box around this because, again, there aren't any extraneous solutions. Now, should we check ourselves on tests, on the My Math Lab homework? I definitely recommend that you do so just to ensure that you are doing these problems correctly. So on the newer calculators, to check yourself, you're simply going to plug -60 in for x. So 3 to the -60 minus 4, whoops, so -60, my bad, minus 4. Well, that sure is gross. So 2.91 e to the -31. And if we check the other side, 9 to the -60 plus 28, well, that's good. We get that same disgusting number. So as long as you're getting an equality statement on both sides, that ensures that you have done the problem correctly. Now, I said that this is how you check on the newer calculators because on the older editions of the TI-83s and 84s, when you do 3 to the power of -60 minus 4, if it doesn't automatically go to the superscript, you're going to have to do your caret button and then parentheses -60 minus 4. So older calculators, make sure you're putting those parentheses in. Otherwise, you're going to think you're doing these problems incorrectly when in actuality, you are doing them right. So it never hurts to check yourself, but there aren't any extraneous solutions that we must check for on these exponentials. So moving on to number 2. On this problem, we first identify it as an exponential equation because my variables are up in the exponent. So we look at our bases. We've got 1 over 4 and we've got 64. They are isolated. There's nothing being multiplied to those bases, subtracted, or added. So first step is done, isolating the bases. So can we write these as the same base? So we've got a fraction and we've got 64. If you want, you can start with the 64. Again, 64 being a perfect square usually jumps out to me first. But if I write 64 as 8 squared, can I write 1/4 as base 8? The answer is no. So I can't use base 8 for 64. We want to take it down to a even smaller base. So I'm going to go ahead and replace it with 4 cubed raised to the x minus 1. Now, could we take that all the way down to base 2? We sure could, but if you don't have to mess around with those smaller bases, I certainly wouldn't. So base 4 is good enough because now, looking at 1/4, I can rewrite this as 4 to the -1st. So remember, how do we give that 4 a bad attitude and send it to the downstairs of that fraction? We use a negative exponent, and then we have 2x plus 2. So now, simplifying those exponents by distributing our new exponents, we get 4 to the -2x minus 2. And again, always be careful that you're distributing to both parts of the binomial exponent. That's normally an issue that I see with my Algebra 2 students. So 4 to the 3x minus 3. So now I have the same bases, so I can cross those off and drop my powers to ground level. So -2x minus 2 equals 3x minus 3. And now we have a ground level Algebra 1 equation. So my x is no longer in the exponents. We can add the 2x over to the right side. We can add the 3 over to the left side. And that gives me 1 equals 5x. So careful you don't rush things because to isolate that x, we would want to divide by 5. So x is equal to 1/5. And I do encourage you, try plugging that in on your calculator to verify that you get the same thing on both sides of the equation.